In this lecture, we'll be covering sampling and sampling procedure. Let's remind ourselves, the population is all units of analysis, all cases, all observations, all individuals, groups, events that exist for a specific topic, whereas a sample is a subset of those units of analysis from within that population. So, if I wanted to survey SDSU undergraduate students, my population would be all undergrad students at SDSU. However, a sample would just be a subset of those students, maybe 500 or 1,000 undergrad students from SDSU. Why do we cover this issue of sampling? Why do we go out and take samples? Why not just take the population? The simple answer is it just takes too much time and energy to collect data about a population because of the size of the population. Say we wanted to collect observations from the population of the United States. We would be collecting data for a long period of time. It would take us years to collect all of those observations. We would also have to account for people who passed away during that time and people who were born during that time. So the population would continue to change. We would never get around to actually collecting information from the entire US population. Therefore, it's time consuming. It's expensive in the sense that it's going to take us a lot of money to travel across the entire United States to collect information from everyone. It takes a lot of energy. One person going out and talking to millions of people would take forever. Okay, 2 people, okay, you'd split that time in half. 3 people, a third of the time, right? But still would take a really long time. Sampling is the exact process of how we go out and select the units of analysis for our sample. So sample is the subset. The process of sampling is just how are we going to select those people? How are we going to select those events? How are we going to select those observations? There are generally 2 types of sampling categories. One's a non-probability sampling technique and one's a probability sampling technique. Non-probability sampling is selecting the units of analysis, selecting our observations based on convenience to the researcher, meaning if it's easy for me, the researcher, to collect it, then it would be a non-probability sample. In addition to that, it's not based on probability theory. Probability sampling is just selecting units based on probability theory. So this idea of we can estimate the probability of inclusion or exclusion in our sample based on what we know about the population. Whereas in a non-probability sample, we can't estimate what a person's likelihood of being in my sample is because it isn't based on a systematic technique. Let's take, for example, we wanted to collect information from SDSU students. A non-probability sample would be standing in the student union area and talking to and asking questions or surveying every student who walked by the researcher. And that's non-probability because we don't know the probability of somebody being on campus that day or the probability that they're going to walk past the student union during that day or even be around during the time that the researcher is at the student union. Whereas probability theory says we're going to get a sense of how many people exist and what is their likelihood of being here on these days. Which method do we use and when would we use them? So if we're engaging in a non-probability sampling technique, we want to use it when the researcher wants a non-representative sample. They don't want to generalize to the larger population. Remember, we take samples because we want to get a subset of the information from that population, but we want to say something about the larger population. With non-probability techniques, you can't really do that because we don't know if our sample looks like the population. Therefore, it's non-generalizable. We can't provide exact estimates of likelihood of being included or excluded from the sample. On the other hand, when we're engaging in probability sampling techniques, we want to say, here's everybody in the population, here's each person's likelihood of being included in my sample. Therefore, based on that likelihood of inclusion or exclusion, we can generalize to the population. So this idea of generalizability relates to making claims about a population based on what you've done in your sample. Representativeness is this idea that the sample that we collect is going to have the same distribution of characteristics at the population from which it was selected. So if there are 10% of SDSU student population are freshmen, then we would expect that 10% of our sample of those students would also be freshmen. A sample is representative of the population if all units within the population have an equal chance of being selected for that sample. Therefore, we can make generalizable claims. Everybody has an equal chance of being included in that cross-section that we're collecting. And when we engage in probability techniques, we can eliminate sample bias or error. We want our sample to look or represent the larger population. And we can only do that if we know something about the population and we know everyone's likelihood of inclusion or exclusion. There are certain kinds of research questions that we can engage in where we can use non-probability sampling, but generalizability is the main goal of probability techniques. So here's an example. A lot of people like to use the soup pot example. I, on the other hand, love burritos. So I'm going to use burritos as the example. Here we have on the left the population, which is the entirety of that burrito. On the right, we have two kinds of samples. We have a non-probability and a probability sample. A non-probability sample would be one that is non-representative of everything that's in that population or of everything in the entirety of the burrito. We look at this burrito, it's a pretty big tortilla and it's a breakfast burrito, so there's egg and pico and sausage and bacon and things like that. But the tortilla is only a sliver of all the stuff that's inside. But in this first example of non-probability sampling, when you go and take a bite into that top of the burrito, what happens? You're getting a mouthful of tortilla. Now, is that mouthful of tortilla representative of everything in that burrito? No, that bite full of tortilla, it's not fully representing all of that. So you would think if you just took a bite, this burrito is only made of tortilla, whereas the entirety of the burrito is only 10% tortilla. So that would be an example of a non-probability sample. A probability sample would be representative of everything that's in the burrito. Here we see a cross-section of the burrito, sliced right from the middle. When you take bites of that burrito, it's going to look like this. So this is a better example of what we're doing in probability sample. We want it to look very close to the mixture that's in the population burrito. We can use each of these sampling techniques for various sorts of research. Oftentimes, non-probability sampling is associated with qualitative research, and probability sampling techniques are associated with quantitative research. If we know something about the probability of being in or out of a sample, then we can say something about how close that sample looks to the population. And we can be relatively certain about extrapolating these statistics to the larger parameters in the population. There are cases where qualitative research also uses probability sampling, right? We're going to select people to be in our qualitative study based on what we know the population looks like. So when we're engaging in non-probability sampling, what we're doing is trying to understand meaning. How do people understand the social world around them? Let's talk about their experiences with some social phenomenon, their experiences with this kind of relationship. We're not trying to say that our non-probability sample reflects everything that's going on in the population. We're just saying, here's a subset of people based on convenience. We want to talk about their experiences and how they make meaning of their own social world. So in that sense, we can't generalize those meanings, those experiences to the larger population because we don't know if it looks exactly like the population. Probability types of sampling techniques are really about finding statistical association between variables. Probability samples are the basis of inferential statistics. It means that because that sample looks so much like the population, we can infer that the relationships we see in the sample are going to be reflected in the population as well. There are specific methods of sampling by these types. We have amongst the non-probability type, we see sampling available subjects, snowball sampling, purposive sampling, and quota sampling. In probability sampling, we see simple random sampling, we have systematic sampling, we see stratified sampling. There are tons of other sampling techniques, but this just gives you a brief overview of what they look like. Again, non-probability sampling is best for non-generalizable research, often used in qualitative research. Available subjects is a type of non-probability technique that is used when the researcher just wants to make it easy on him or herself. Available subjects just means that, like the example I gave earlier, I'm standing in front of the student union and whoever walks by will be selected for my research. It's based on proximity to the researcher. And we can see in this example, everything up here represents the population. If I'm a researcher and I'm standing right here and I say, hey, everybody who walks by me, I'm going to survey for my sample. I'm going to have 7 white women and 3 white men. While this may look like it is sort of representative, it's completely excluding black women and black men. Also, we end up with a larger proportion of the sample that is white women relative to the entire population. Our sample will not look much like the population. Snowball sampling. This is a common technique used in qualitative research, especially with interviewing. Snowball sampling is a technique where each person who's interviewed is asked to suggest an additional person to be interviewed. In this sense, I say, hey, I want to talk to you about your experience with protest participation. I interview you, and then at the end of the interview, I say, would you like to suggest anybody else who I could potentially talk to about protest participation? So then I contact that person, I interview him, and at the end of that interview, I say, hey, do you have anybody else you would like to suggest for this research? So then I interview that woman, and so on and so forth. And it's this idea that the snowball sample is getting bigger with each iteration. You're collecting information from new individuals that have been connected to the previous individual. Next, we have purposive sampling. Purposive sampling is just another non-probability sampling technique, and the units are selected based on a researcher's judgment. It's just saying, I'm curious about this characteristic, and I only want to talk to people with this characteristic. Quota sampling. It's very similar to purposive. Quota just says I need my sample to have specified characteristics. It usually does match the larger population in terms of the proportions of various social groups. Usually when quota sampling, I'm trying to get, say, 5 African American males between 18 and 24. So as long as you reach that number, you've met your quota, and then you can move on to another subset of your sample. So that's what quota sampling is. When you're engaging in non-probability sampling or a qualitative type of sampling technique, you want to consider a couple of things. First is selecting your informants and gaining entree. We have selecting informants, that is, selecting someone in a group that you're interested in. So if we're looking at SDSU students, selecting someone amongst that target population who is well-versed on that topic, someone who will be willing to tell you what they know and what they understand about the group so you can get more information and they can start introducing you to other potential participants. This kind of consideration is important when you're trying to understand social organizations or specific social groups that you don't really understand. A lot of groups are sort of hesitant to engage in research. So selecting informants is one way that you can interact with people in these groups by having someone who can vouch for you, which is related to gaining entree. So you meet the gatekeepers of that group and you develop a personal relationship with them. They can serve as a springboard for the rest of the group trusting you. So whereas selecting informants is just identifying somebody who can tell you about it, gaining entree is working with those informants to introduce you to that social group. Say, hey, we should trust this researcher because I've been working with him or her for a while and I trust that they're not trying to harm our group. Probability sampling. It's best for generalizable representative research or making statements about the population. It's necessary for quantitative research, but it also can be used for qualitative research. How do we abide by the logic of probability theory? How do we ensure representativeness and generalizability? Well, there are 2 things that you need to consider. Each time you're trying to sample and you want to abide by the logic of probability theory, you need to ensure that each unit within that population has an equal chance of being included in your sample, that they will be randomly selected from that population. So this is what we call random selection. In non-probability sampling, not everyone has an equal chance because in our example, we stood at the student union at 1 p.m. on a Wednesday and we just interviewed people as they walked by. That is not probability because not everybody had the equal chance of being included. Not everybody's on campus on a Wednesday. Not everybody's on campus on a Wednesday at 1 p.m. And not everybody who is on campus on Wednesday at 1 p.m. is walking by the student union. However, in probability sampling, we need to ensure random selection. Well, how do we do that? First, if we're going to be sampling from the entire population and we want to ensure that everyone has an equal chance, we have to have a list of all those units or all those people in the entire population. And that is called a sampling frame. It's just a list of all the units in the population. Then we use that list to identify or select which ones will be included in the sample. It's important to think about the structure of the sampling frame. If we think about a sampling frame or a list of all the students at SDSU, the population would be all the students at SDSU, all the undergrad students at SDSU. Sampling frame would be a list of all their names. If we're going to sample from that list, we should randomize that list because we may have a list where certain names appear more frequently. We may see a bunch of students with the last name Garcia or Hernandez or Ramirez or things like that. We have common ancestral names and those are going to be built into the alphabetic structure of that list. So we need to think about that before we start sampling. It's best to randomize the list. So simple random sampling is, like I just explained, all the units on that list are assigned numbers and a set of random numbers is generated. Everybody on the list will be given a number and the units having those numbers will be included in the sample. That way it's truly random. Systematic sampling is just a sample where every kth unit in a list is included in the sample. So here we have an example where you have a list of people, 1 through 12. They're already randomly sorted, and then you say, I'm going to select the second person, and then every kth person after that will be selected for that sample. So K in this instance would be 3. So every third person after that first selection will be included in the sample. When you're doing systematic sampling, it's wise to randomly sort your list, because if you don't, you're going to oversample specific people. Stratified sampling is grouping all of these units in the sampling frame into strata or homogeneous groups. Then you conduct a sampling technique on the entire list. So you can sort all the white men, then white women, then black women, then black men in our list, and we can do a systematic sampling technique. Say every 10th person we're going to select. And because it's sorted in a specific way, based on their strata or their background, we're going to select people from each group. These homogeneous strata can be anything. You can break down by race, class, gender, and important characteristics for the topic of research. Just know that when you're breaking your population down into strata, it's going to be difficult if you have a lot of different groups. So keep that in mind. Like I mentioned before, there are a lot of other sampling techniques that can be used that we won't cover in this class, but feel free to investigate on your own on the various sorts of ways that you can sample from a population.